By calculation of special trigonometric ratios, we mean calculation of values of basic trigonometric ratios for special angles like theta is equal to 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. For calculation of basic trigonometric ratios, let us first consider a point P with coordinates x, y on a circle with radius equal to r. So if m is foot of the projection of P on horizontal axis, x-axis, and if we consider this as y-axis, then from triangle OPM, from triangle OPM, when central angle is theta, when central angle is theta, what would be the values of sine theta, cos theta and tan theta? Sine theta would be equal to, sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. For this triangle OPM, for triangle OPM, we can see that opposite is equal to y. Opposite is equal to y and adjacent is equal to x, while hypotenuse is equal to r. This means we can redefine sine theta, cos theta and tan theta in terms of x, y and r. This means sine theta is equal to y over r, cos theta is equal to x over r, and tan theta is equal to y over x. Now this is how we can redefine sine theta, cos theta and tan theta with reference to triangle OPM, where opposite is equal to y, adjacent is equal to x for angle under consideration theta. But we can see that if when P moves around the circle, if P becomes closer to its initial side, means that when theta starts decreasing, y starts decreasing as well, and when theta increases, y increases. When theta approaches to 0, when theta approaches to 0, like the central angle becomes so small that it is almost equal to 0, then value of y approaches to 0, because the height becomes less and less. The opposite of the triangle becomes smaller and smaller, and when theta becomes equal to 0, y is practically equal to 0, and at that stage x and r are almost equal. X becomes equal to r, and this is when theta is equal to 0. So when theta is equal to 0, this will be our first special trigonometric ratio. When theta is equal to 0, then sine of 0 degree would be equal to 0 over r, cos theta would be equal to, this would be cos 0. Cos 0 degree would be equal to r over r, and tan theta would be equal to, where this would be tan 0 degree would be equal to 0 over r. Means that value of sine 0 degree would be equal to 0 and cos 0 degree would be equal to 1 and tan 0 degree would be equal to 0 as well. Let us now consider the case when theta is equal to 30 degree. So let us consider this case when theta is equal to 30 degrees. If that is the case, we will redraw the figure, and here is the new figure, and let's consider that this angle now is equal to 30 degree. If this angle is 30 degree, then this angle is obviously 90 degree. What should be this angle? This angle, being complementary angle of 30 degree, must be equal to 60 degree. And this side being equal to r, this being y, and this being equal to x. From 30 degree, from 90 degree, 30 degree and 60 degree rule for right angle triangle, we know that if this hypotenuse is equal to r, then x must be equal to under root 3 times r by 2, and y must be equal to r by 2, just half of the hypotenuse. We have done this in earlier lessons. You can refer it to that lesson, and let's name this triangle as O, P and M. Then from triangle OPM, sine theta which was equal to y over r, cos theta which was equal to x over r, and tan theta which was equal to y over x. At this stage, sine of 30 degree would become equal to, when central angle is 30 degree, sine would become r by 2 divided by r. So this will become equal to 1 over 2. And cos 30 degree, which is equal to x over r. Now let's put down the values of x. So this would be under root 3 r over 2 divided by r would be equal to under root 3 over 2, because r will be cancelled with r. So this is value of cos 30 degree, and similarly we will find out the value for tan 30 degree. Tan 30 degree would be equal to value of y over value of x, so that would be r over 2 divided by under root 3 r over 2. So this will be equal to 1 over under root 3. These are the values for sine 30, cos 30 and tan 30. So in nutshell, we can just write down the results. Sine 30 degree would be equal to 1 by 2. Cos 30 degree would be equal to under root 3 by 2. And tan 30 degree would be equal to 1 over under root 3. Now when theta is equal to 45 degree, case 3, when theta is equal to 45 degree, we again bring another triangle in here, and if this angle, central angle, is 45 degree now, then this is y, this is x, this is r, and we know that if this is equal to 1, if x is taken as, because if this is 45 degree, then this is 45 degree as well, the complementary angle, because this angle must be 90 degree for right angle triangle, and complementary angle of 45 degree is 45 degree as well. If two angles of a right angle triangle are equal, then sides opposite to the equal angles are also equal. Since sides opposite to equal angles are equal as well. So if x is taken equal to 1, then y is also equal to 1, and this should be taken as under root 2. So in that case, this is, if this is equal to 1, y is equal to 1, and this is under root 2. But if you want to take this as radius r, then this would be radius r under root and r under root as well. Anyways, sine theta is equal to y over r, cos theta is equal to x over r, and tan theta is equal to y over x. And if we apply these values, then sine of 45 degree would be equal to one over under root 2. Cos theta means cos of 45 degree, that would be 1 over under root 2, and tan of 45 degree would be equal to 1 over under root 2, 1 over 1. So that would be 1 over 1. This would be equal to, so these are the values for sine theta, cos theta and tan theta. And now when theta is equal to 60 degree, again we have the same. Let's bring another triangle here, and this time this angle, central angle is 60 degree. This is 60 degree and this is 30 degree. And this is of course 90 degree. If that is the case, again by using, if this is R, this is Y, this is X, by using 90 degree, 30 degree, 60 degree rule, if this is R, then this would Y would be equal to under root 3 times R by 2 and X would be R by 2. Sin theta is equal to Y over R. Cos theta is equal to X over R, and tan theta, which is equal to Y over X, means sine of 60 degree would be equal to under root 3 R by 2 divided by R, and cos of 60 degree would be equal to R by 2 over R, and tan theta, which is tan 60 degree, would be equal to under root 3 R by 2 divided by R by 2. So this means sine 60 degree is equal to under root 3 by 2, cos 60 degree will be 1 by 2, and tan 60 degree would be equal to under root 3. And now for theta is equal to 90 degree. When theta is equal to 90 degree, X becomes smaller and smaller and Y becomes bigger and bigger. When theta is equal to 90 degree, X approaches to 0, Y approaches to R, and theta approaches to 90 degree. Or we should say, right, when theta approaches to 90 degree. In that case, sine theta, which was equal to Y over R, cos theta, which was equal to X over R, and tan theta, which was equal to Y over X, will now become sine 90 degree equal to R over R, cos 90 degree equal to 0 over R, and tan 90 degree equal to R over 0. This means that sine 90 would be equal to 1, cos 90 would be equal to 0, and tan 90 degree will approach to infinity because 0 is the divisor and it is not defined.